Good morning, folks. This is a three-part presentation about Informix 14.10 and some of its real cool features. Carlton Doe and Scott Pickett will take over from here. Thanks for coming in. Good.
Good morning, good afternoon, and maybe even good evening to some of you. My name is Scott Pickett, and I'm the Worldwide Technical Sales Strategic Partnerships Chief Cook and Bottle Washer for Informix. And today we're going to talk about the entire release of Informix in reverse order, at least in my presentation. We'll be dealing with a brief mint on XC9 and going through XC7, 6, and 5. And then later on, I'll come back and do 4, 3, 2, and 1. Your level of detail drops as we get older, simply because a lot of this stuff has been presented before, but we wanted to do a little bit of a review. The other thing I wish everybody to be aware of is that I have recently been recovering from COVID, so once in a while my voice cuts out, and I may cut out for a second or two in the presentation. That all being said, let's get going.
Scott, if I may.
Yes.
If people have questions, put it in the chat area, and I'll be responding to them while you're giving your presentation.
Sounds good. So in FC9, which is the latest and is out now, there's no new features here whatsoever. However, there are an awful lot of bug fixes, as you can see here on the screen. And there's 176 defects fixes and 75 APARs dealt with. So if you're planning to upgrade to 14, this is an excellent point to go to for whatever release and edition that you happen to be on. So these are some of the features released in FC7. Carlton is going to talk about FC8 and replication. So HQ got some upgrades on secondaries. Through which HQ allows or restricts certain actions on server types. Cluster consists of primaries and secondaries, and HQ will treat every server added as an individual server. Depending on the server type in the cluster, the Informix server allows or restricts certain actions based on certain server types. From XC7 onward, it handles all such operations on secondary servers in the cluster. The schema manager has been enhanced, new SQL editor, enabling users to write custom SQL and display query tree plans in graphical format. We enable SQL tracing on the Informix server to view a query execution plan, and if it's disabled, the SQL editor provides an option for ease to enable it. Unchecked -W now has an option to wait on locks measured in seconds, and if it encounters a lock while performing its work, it first indicates to the user that it's waiting, and then it will pause until either the given timeout expires or the lock is acquired. The W option can be appended to any onCheck command. The onCheck encounters a lock while performing its work. It will either indicate to the user that it's waiting or pause until which time as the given lock timeout expires or the lock gets acquired. And it has some return codes which are non-zero if the utility exits due to a timeout expiration. Option may be given a number of seconds to wait, for example, here on the screen. It'll wait up to 10 seconds in this particular example for each lock encountered during the data and index check of the customer table. And omitting any timeout value tells the onCheck to wait indefinitely for locks, as shown here on the screen. An onCheck using the -W option can maybe interrupted at the command line as usual, even when the command is waiting on a lock. So for the longest time, index information was one of the big black holes on the OnStats. You literally couldn't get any information on it because there wasn't an OnStat available. So this is OnStat minus I, not L, I. This is one of those little things, capital letters versus small letters. Index operation statistics include the reverse scans and retries. Instance-wide information only, not down at the partition level just yet. We would like that, though, I would imagine. Index statistics, sample copy shown here on the screen. It deals a lot with the B-tree merge operations, in one in which two index nodes in the same level are combined into one, with all index items to the right-hand node being moved on to the left-hand node. The empty node then gets unlinked from the tree and page marked free in the partition's bitmap. A B-tree split operation is the opposite of a merge. A new node gets added to the right of the nearly full node, and about half of the index items are moved to the new node. There are also shuffle operations indicated in OnStat minus L, balancing the number of items between two nodes, moving some of the right-hand node to the left-hand node without removing either node from the tree. A shuffle operation now occurs only when an index is being externally compressed using the SQL admin API index compress argument. An internal B-tree compress operation predates the externally triggered index compression feature mentioned above and is unrelated to it. It's simply an unattempted merge operation, and it may or may not result in a change to the index structure. A copyback operation on OnStat minus L is an indication of an update to the parent node when merges or splits on the level below to render one of the parent key's values out of date. Whereas a B-tree search moves downward through a tree, a scan moves sideways through one of the levels, proceeding normally from left to right, from lower values to higher values. A B-tree scan that moves from right to left is called a reverse scan. So we also have more information provided on OnStat-G raw. Been significantly enhanced and breaks down read-ahead statistics by partition and thread. 4 new sysmaster pseudo tables provide an SQL interface to the same read-ahead information. So here's some basic syntax for you with options. Each one of the items has its own structure. And the output for this command is divided into 6 separate sessions: read-ahead data, active read-ahead queues, active read-ahead daemon, recovery read-ahead statistics, partition read-ahead statistics, and thread read-ahead statistics. Running the command without any arguments displays all 6 sections by default, and this output occurs over multiple screens. To display the information for only one section, you add the section name as showed here on the screen. Here I'll show one of what some of this output looks like. Some of the various different bits of data that you can look at. And in FC8, some of this changes yet again. This is useful in tuning auto read, And if the total read pages equals total use pages for a partition, then the read ahead is good. If overall this is not true, then your read ahead needs tuning. This was a request from a single user, indicating that we do pay attention to requests from our users for various new features. So, as I said earlier, there are 6 different sections here. It's rather lengthy for me to go through each one of those. I'm going to be posting a presentation with all the data. It's about 400 odd slides, that and some other things. Yes, root is shown twice, Kate. It has explanations, and you'll see that in the finished proposal presentation that I have, which I'm going to post a link to at the end. My apologies for an abbreviated presentation on that, but it is actually fairly lengthy, and we don't have the time to do all of it. So the CDC set full row logging function has had some updating for the change data capture. You run it as user Informix to enable full row logging on a table from which you intend to perform data capture. The change is that you have to stop capturing data from a table using CDCN capture before you can disable full row logging using CDSet full row logging. And without doing this first, you get an error letting you know that you should have done it first. Chunk mirroring was enabled permanently. This is a discovery that Carlton made. Congratulations to Carlton for finding this. I certainly didn't. Chunk mirroring has now been enabled permanently, and in the process, the configuration parameter mirror has been deprecated. In 14 FC6 or earlier, if mirror is disabled, the value gets ignored. Otherwise, the mirror parameter has been removed in 14 FC7. If the root space in your instance is not mirrored, you should either remove mirror path from the config file or ensure that it is unset. If you use FC6 or earlier, the file where the mirror path is populated with default values, that value is used to create a mirror of the root space regardless of any mirror value in the file. This only affects newly created instances. Pre-existing instances with in-place upgrades do not create a mirror chunk, but rather generate an error, as seen here on the screen. Again, thank you, Carl. So Java and GSKit got some upgrades during this time. Internal Java version was updated to 8.0.36 on most platforms, with the following exceptions noted below. And the GSKit installation was updated to 8.0.5525. FC6. A fairly large number of features in this particular release that had some enhancements and in some cases some new features entirely. The HQ user interface framework is upgraded to Angular 8. HQ gets enhanced by supporting stronger hash algorithms for passwords by adding a new configuration property under the configuration file for HQ. Parameter user password algorithm. It sets the algorithm for HQ's login password. Encryption algorithms supported by HQ are as shown here on the screen. And you can now save dashboard preferences in the custom dashboard page. And the HQ start and stop service script now does at this time support AIX. I have a problem with my presentation. Give me 1 minute. My apologies. That has never happened to me before, and I don't know why. Or I didn't check it. The Schema Manager now supports create and doc table, the addition of a test connection button on the server setup page. The SQL editor displays ISAM error messages that are now returned by the server. There's an enhanced incidents list with new features. Suppressing and repeated alerts is available. Secure connection with agents, and upgrading logging from logback to log4j2. So you can do a create and drop table, allows users to create a table in Informix DB from the UI, simple screen navigation. You can see your SQL statement before execution on a create table and drop your table in the Informix DB from the UI. The login went to 4J2. This is what caused us to release the patch. So if you're going to use this particular feature, you should be on FC7 W1 or download the workaround posted on the IBM website as shown here. For those of you who are on AIX, this will be of interest to you. The rest of you, I don't think that will be too interesting, but this is something I think that will interest you. On AIX Power 8 and Power 9, there's something called large segment addressing. It significantly improves performance of memory retrieval if the number of memory segments is kept to 12 or fewer and they align now on a 1 terabyte boundary. The feature is only on by default for FC6 and higher, and it's not backported. The AIX memory translation table is default size of 12 slots behind the scenes in AIX Power, and the default size for AIX only is small, and normal segment size is 256 megabyte segments. This causes a noticeable performance drop as the number of segments exceeds 12 for any reason, and now these are AIX memory segments we're talking about. The fix does mean we're attaching the processes aligned at a 1 terabyte boundary instead of the default 256 megabyte boundaries for database server memory. It allows for larger memory footprints without the performance degradation. It doesn't mean that we're using a 1 terabyte for each SQL operation. Performance increase is up anywhere between 10 to 40%. Without the feature, as your workload increases, the performance does degrade. With the feature, the workload increases and the performance does not degrade. This was something as a consultant that I saw many years ago, by the way, so this has been around in the product for a while. With the feature on, if the number of segments goes above 12, there is no noticeable loss of performance in the server. If the feature is off, the performance degrades here with more than 12 segments. So, for example, at the top here of the image, you can see a 256 megabyte boundary in effect just by looking at the addresses involved. And at the bottom, the new configuration parameter only for AIX underscore LSA, when set, it will create 1 terabyte boundaries. Large message segment enabled, it resets the 256 megabyte shim base boundary on AIX only to reset to 1 terabyte. The configuration parameter AIX LSA, the settings are as follows. 1, you get 12 segments aligning minimally on a 1 terabyte boundary. 0, you get 12 segments on 256, which is the old behavior. Or 2 will allow you to combine your first and second resident segment, and this will properly handle shimvert sizes greater than a single terabyte. On AIX 7.2, Power 9, 14.1 FC6 reduced the number of segments by sharing the first virtual segment with the resident segment set in AIX LSA equals 2, shown here on the screen, using the same memory key, which used to be possible in Solaris releases at one time. We brought this feature back to AIX 7.2 and below, aligned on a 1 terabyte boundary, but only using what's necessary. And notice the second entry on the file there, it shows us shared memory segment size much greater than 1 terabyte. Setting resident equals -1 seems to work for small shimvert sizes with AIX LSA under 2, but large 1 terabyte or so greater can cause server crashes when you set resident equals -1. So one of the things that I think is very important that we've done for those of you in particular who are using Informix database servers as the backend to web-based applications of any kind, we now support Transport Layer Security TLS version 1.3 for network connections. That is important because TLS's 1.2, 1.1, 1.0, 0. Whatever have all been hacked across all of the database platforms sold in the marketplace, not just Informix, any database vendor. This is a very hackable situation, and we want everybody to be secure, so it is a recommendation that you try to upgrade to 1.3 as is possible for your installation. It underlies the SSL's connectivity and SSL's successor as well. It's an industry standard for web browser database access since July of 2018 and provides cryptographic protocols for client-server connections. TLS version specifies the TLS version used by the database server for network connections, and it changes the values to take effect after a server reboot. On config.std, the default value is unset. You get one or more possibilities for TLS versions, but as of FC8, 1.0 and 1.1 have now been thoroughly deprecated. We now are left, as of FC8, with 1.2 and 1.3. GSKit does not support FIPS mode just yet. If the server offers 1.2 and 1.3, then the preference for FIPS will cause a connection via TLS 1.2. Limiting a server to TLS 1.3 will require disabling FIPS mode by a client. JDBC support for TLS 1.3 requires Java 11. Audit the syslog is normally a very lengthy presentation of about 50 slides. We're going to consolidate it to just a couple and tell you what it's about. Syslog servers are in line with the payment card industry data security standards, rules, and compliance for the credit card and banking industries. Syslog servers are on the same internal network as the reporting devices to be compliant with PCI DSS. PCI DSS compliance reports check whether syslog servers to which the devices log data are on the same internal network as the devices, or whether they are outside a firewall on an external network. Network connections to and from can be encrypted. And the feature is the result of the credit card industry request for a better auditing capability than standard Informix auditing. So there are 12 requirements here for syslog. Again, it is a credit card industry item. You're not necessarily required to do this if you're outside of the banking and credit card industries. However, it is interesting that you can do this to an off-server situation that's still inside your firewall configuration. So you have to install and maintain a firewall configuration to protect data. Don't use vendor-supplied defaults for system passwords and other security parameters. You have to protect the cardholder data, encrypting the transmissions of data across open public networks. Use and regularly update antivirus software or programs, and there are lots of steps involved in all of these to prove compliance. You need to know restricted access to cardholder data, a unique ID to each person with computer access, restricting physical access to cardholder data, track and monitor all access to network resources and cardholder data. And so this is auditing, and for Informix, obviously via audit, and to syslog externally at that. Regularly testing security systems and processes, and finally, maintaining a policy that addresses information security for all personnel. This is a set of standards at each one of these steps that you have to prove in order to be certified to be compliant with PCI DSS. If you're outside that business, obviously you don't have to comply, but you can, don't have to follow the standards, but you can still use it. What it isn't is a method of directing Informix Classic auditing output to an off-server instance that's running on an Informix database. There are new features added on audit and on show audit, but they are syslog oriented in nature. Distributed transactions and PAM authentication. Informix now provides an additional method to support distributed connections with PAM authentication. On Linux and Unix platforms through the OSR hosts PAM module, users can define PAM as the configuration file. When Informix initiates a distributed connection after the session is established, it cannot respond to authentication challenges because the timing becomes unpredictable. A password required to connect to the local server might not be the same as a password required to connect to the remote server. Consequently, authentication for distributed connections must be completed by the remote server on the basis of trust, and the remote server must trust the local server, and remote administrators must explicitly permit the user to connect to the local server from the local server to the remote server. My apologies. Two methods to support. First one is via sysuser sysoff, recording trusted remote servers and the host on which those servers run, and controls incoming connections from other servers. If PAM or LDAP is enabled on the remote server, the sysadmin can then enter authorized users in sysuser sysoff for each remote server. Fields for sysoff are shown here on the screen. Table can contain different multiple rows for a single user to prevent connections from different servers and different hosts. There's a unique index on username, servers, and hosts, none of which allow nulls. The group name column must be empty. Any value in the column is ignored. For example, to permit the server to accept distributed transactions from a user known as user1 from a database server known as server1 running on a host, host1.example.com, shown here on the screen. For forward compatibility, ensure that each table row identifies one username, one Informix server name, and one host name. Don't use any space-separated lists of servers or host names in one entry. It will not work. Method 2, on Linux and Unix platforms through OSR host PAM module, for example, define your PAM configuration file as shown here on the screen. SEC non-blocking checkpoint. For years, we've had non-blocking checkpoints because it turns out on the secondaries in an HA cluster, we never did have non-blocking checkpoints. They were always blocking. And then the result was we sort of wound up having a ceiling by which we could not get performance to go any faster. So we have changed all that now. So the values to setting this configuration parameter are enabling non-blocking checkpoints at HDR and RS secondary servers. Set that to 1, and you will no longer have any blocks on your checkpoints. 0 is legacy, disabling non-blocking checkpoints. It takes effect after you edit your on-config file and restart the database server, or by the usual on mode -WM or WF usage. SEC non-blocking checkpoints controls the checkpoint behavior at HDR and RS secondary servers. Non-blocking checkpoints are 500% faster than blocking checkpoints and desirable for all server types. And when it's enabled, the HDR secondary applies blocking and non-blocking checkpoints just like the primary server. This was benchmarked in the lab at 500% performance improvement on non-blocking checkpoints. Make sure your physical log size is equal to or at least 110% of the buffer pool size, please. Temp table no log. It can now have a value of 2 previously. 0 enabled logical logging on temporary table operations. 1 disabled logical logging on temporary table operations. And it took effect on mode -WM, WF. Now when it's set to 2, the temp table no log enables logical logging on temporary table operations for the primary server and disables logical logging on temporary table operations for secondary servers. On a primary server, standard server, it's the same behavior as set to 0. On secondaries, it's the same behavior as set to 1. When a server type changes, logging for temp tables will be enabled or disabled depending on the current server role. It will be effective for temporary tables created afterwards. You can improve application program performance as it prevents Informix from transferring temporary tables over the network. If enabled, since temp tables log no data, rolling back a transaction on a temporary table will no longer undo the work in the temporary table. So enterprise replications had some improvements, a new utility, CDR check catalog. CDR check catalog compares metadata info related to servers, replicates, and replicate sets on replication servers for any inconsistencies. Syntax shown here on the screen. Target server is the name of database server group to check. It must be the name of an existing database server group in the SQL host file, and syntax is that of a very long identifier. Options are as follows: -A, -M, -V. You can see their meanings in the far right-hand column. If you wish to use the long form, you can do that as well. Belief servers specified with connect or master options. Parent servers are used instead, and you run it from within an SQL statement by using the SQL admin API. Following command generates a consistency report comparing the master server gserv1 metadata with the server gserv2 metadata. Seen on the screen, you see the report. And in this particular case, the metadata is consistent on all of the servers. Enterprise replication has been enhanced in FC6. Behind the scenes, FC6 and beyond has undergone some performance improvements, and there's not a lot for you to configure. Most of the changes are under the covers. The net result is that ER is very much faster at replicating and syncing data from one node of an ER cluster to another. From 5 to 18 times faster for two same OLTP servers, source and target. 9 hours before the feature was invented to 30 minutes after it. Tests and data at a high level were data loads to source server were 80 million rows. 2 hours before the feature to propagate 80 million rows to a target. 8 minutes after the new feature was implemented is how long it took to propagate those 80 million rows. 10 million rows before the feature was 15 minutes. After the feature, it was 1 million. 15-time improvement. 9 hours to do previously is 30 minutes with the new feature. Once data is loaded on a target, benchmark was started. Tables then truncated on target. ER sync then started to the target. Before the feature, when ER started spooling, the transfer falls to 500 per second from 2,000 per second. After the feature, we reached 10,000 per second and stayed there. Previously, it took 9 hours total. Now it's only 30 minutes or 18 times faster. For ER sync and ER resync, it was a 2 to 4 time improvement. New improvements start on FC6 only and beyond. To migrate, empty your queues. Log replay is current. Outage is required. A normal procedure. After that, and upon a restart, do a CDR clean start to restart and clean up behind the scenes. They also changed the communications protocol behind the scenes. The old NIF mechanism has been completely replaced because it could get blocked on a network call and could not use more than one network pipe. And it was changed to SMX, which does not have those limitations. Some of the other optimizations, most of this is all under the covers and of no concern to anybody on the call. You don't have to tune it. Just want you to know what we did for those of you who are interested in some architecture. So you get parallel applies, ET updates, and ACK queuing. A network interface was all SMX. – 'NIF' send threads were optimized to do minimal latching. – 'NIF' send threads were optimized to do minimal latching. – 'NIF' send threads were optimized to do minimal latching. 'NIF' send threads were optimized to do minimal latching. 'NIF' send threads were optimized to do minimal latching. 'NIF' send threads were optimized to do minimal latching. 'NIF' send threads were optimized to do minimal latching. 'NIF' send threads were optimized to do minimal latching. 'NIF' send threads were optimized to do minimal latching. 'NIF' send threads were optimized to do minimal latching. 'NIF' send threads were optimized to do minimal latching. 'NIF' send threads were optimized to do minimal latching. 'NIF' send threads were optimized to do minimal latching. 'NIF' send threads were op during a queue traversal, optimizations related to spool-only transactions, and it doesn't block on network, and some of the other improvements are listed here below. So the lab directly has some recommendations for enterprise replication configuration changes, as you can see here on the screen. And for a minute, given that you all don't necessarily use ER, and some of you do, I will pause here to let you read this before I move on. Some changes to SysDR database. CDR transaction apply. One row in a progress table for a given replicate and source ID. Progress table overview. Transaction key gets inserted as soon as we do work on a transaction. Commits don't update the progress table immediately. When we're ready to send an acknowledgement, we still serialize the acknowledgements based on the source commit order. When ready to send an acknowledgement, progress table is updated. If the server is killed and restarted, if a transaction has been duplicated and not seen in the progress table, we skip the transaction as it has already been applied upon the progress table lookup. CDR transaction apply handles the saving of transaction keys already applied, so if ER disconnects and reconnects, the table is used along with the receive queue progress table information to check application status of a given ER transaction. Communication mechanism change between log snooper and grouper thread to the group relation threads. We still do use ring buffers with RSAM, buff queues. And we do a multi-get API created earlier in a cluster log replay performance improvement is used to allow us to use multiple buffers in parallel with less locking as the result. So locking improvements occurred in the group of threads. Queuing, if too many spooler transactions were queued, the network send threads would block and now no longer blocks on the queue mutex at the network later. Memory transactions remove latching, which remove blocking on the if send threads, and recently tested at a client site with 4 12.10 servers received from a single 14.10 server as an upgrade from 12 was 70% faster. This was very recent in the last month. OnStat-GLAQ received some enhancements. You now see the secondary queues. An overall log record apply rate is calculated and shown. Use it during logical log recovery only, otherwise an OnStat header is printed. If the primary server performance is slowed because logical logs are not replaying quickly enough on the secondary server, monitoring progress made during the logical restore. Monitoring the performance of log apply queues on a secondary server or during any other form of log recovery. And you show information about the log recovery apply queues, which includes logical log recovery on secondary servers and logical log restore or logical recovery part of fast recovery. Log records from logical logs are assigned to replay worker threads according to the table space ID associated with them. A subset of log records will be applied by the master replay thread. For example, in an HA cluster, the primary server sends log records to one or more secondary servers over the network. Each secondary server continuously replays transaction logs from the primary to ensure the data is replicated on the secondary. Each table space on the primary server is assigned a queue on the secondary server in which to receive log records. Replay threads apply log records stored in a queue to the secondary server. The log records are applied in the order in which they were received. In the output of the command, you see an average depth column indicating the average number of log records in the queue occurred whenever putting a new log record on a queue, and the current and last logical SN column specifies the log record a replay thread currently is active on, or the last one it was replaying, with the part val column typically specifying the table space ID this log record refers to. And then there was a transaction pointer and a transaction ID shown for a replay thread indicating a log record currently being applied. On a secondary server, the transaction latency is measured in full seconds, with each end of transaction commit and rollback log record as the difference between local applied time and primary server's end of transaction time shown. The admin command has been enhanced. When it's connected to a secondary node, it's disabled and always return a value of -1. In addition, the task function now will return an error for commands that involve modifying disk structures, since these administrative actions are meant to be executed only on a primary or standalone nodes. There's a new SQL interface for temp space usage. This is something our users have been asking for a while. This has been usable since FC8 of version 12 and 14.10 FC1, and it's now formalized as a sysmaster view. And this is what it returns. For the longest time, we could not have temp spaces of different page sizes. It was always fixed to a standard default page size. You can now do this. Whoops, my apologies. So here we have multiple page sizes for different temp spaces. And this will greatly improve performance. Prior to FC6, all temporary DB space sizes had to be the same page size. Anything different, and the server would not accept it. To overcome possible processing issues, we've always had to have very large temp space sizes, such as 16K in size, the maximum possible. During warm restores, we need the temporary DB spaces to store logical log files. Previously, a warm restore would fail with all temp DB space sizes greater than the default page size. Logical log pages used in warm restores could not be stored in any DB space other than a base page size, depending on the platform. This feature will now allow warm restores in installations using mixed DB space page sizes and other uses as well. Improvements to DB-info, DB space part num. This command at the very top would always generate the error shown underneath. Adding the environment variable shown here on the screen. You'll apologize. I apologize, but I don't think I'm going to read all that. To preserve existing behavior, the default is 0, and when set to a non-zero value, DB-info will return null for an invalid part num. And there is no error -727 raised, except when part num is null. Then when that happens, the error message 727 is still raised. Not using the where clause part num breaks many scripts using sysmaster systab names, and these changes start at 12.1 XC14 all the way up to 14.1 XC2 and beyond. You can set it as an environment variable for the instance, an environment variable for a client like DB access, and a session environment variable. Query timeouts. As a developer, it would be nice if you could go and terminate a properly running query yourself without needing any special access by putting a time limit on a query in advance and watching the query session kill itself when that time limit threshold has been attained. Currently, to terminate such query, you have to do on mode -Z, as we all know. And most folks are not privileged to use that, so the DBA has to kill the query, and you have to go find the person, which might take a little while. So if you set query timeout as a dynamic session level environment variable up to a maximum number of seconds, which is 16,000 seconds. So set environment query timeout 20, we'll wait 20 seconds before we kill a query. Default is 0, which is not set, which means queries run as always with no timeout whatsoever. 1600 seconds equals 267 minutes, which is 4 hours and 27 minutes. So why would you wait that long to kill a poorly running query? Think about how long you want to wait here before you actually set it. So sometimes you can have a bad programming day. So this is a correlated subquery shown here on the screen, and it's deliberate. And the real-time clock time is elapsed on queries only if only is running, but the query timeout variable in this particular screen is not set anywhere. So this query will run a while and may not return data in a timely manner, if at all. Same query runs with the query timeout set to 20 seconds. The clock runs in real time, and the query running time is approaching the threshold of 20 seconds. And after that, it will terminate with any more intervention, shown here on the screen. So its use is obviously to keep poorly written queries from running for a long time. Another use could be to run an entire stream of queries in test mode pre-production, one at a time, with query thresholds set at a required maximum threshold, and then separately at a minimum to see in advance what will be an issue and take corrective measures up front. This might enable tune, test, and repeat far more quickly for singleton test units. Time display here could be off as much as a second due to how this is done behind the scenes. And you can combine this with set explain on, avoid execute. Interesting feature, does not apply to DDL or standalone insert updates and deletes, and it will work with select into, insert into, select star from external table selects. Last table modification time. On check -PT, now records the last time data was modified in a partition. Time on is a newly created DDL. In a newly created object, the time on is blank. Feature is hugely successful to determine which objects have been used recently and which have not, such as a table with 22 indexes on it, for example. Am I really using all of those? How do I know? Which ones can I drop over time? And to save all of the I/O, disk space, and transaction overhead and completion time for each and every one of my transactions that insert, update, and delete both the table and all of its associated indexes. So after studying for a year, you find you haven't used 7 of those indexes in any of the quarters of your processing year. You would save 7x in each of the transactions involving that table in insert, update, and delete operations, because you would not have to create the index nodes any longer, plus all of the disk and memory space of all those indexes. And that represents an awful lot of CPU cycles and disk space and memory space saved. A lot. So why would you have an index? Why would you have a table with 22 indexes on it? Going back to the days when we used to do update statistics, but it didn't have enough buckets. Customers would build an awful lot of indexes to get around the problem. And then those things sit there over time. Now that we've had an awful lot of time disappear, those indexes are still there and many of them won't be used. So this is a good way for you to make a determination on those and eliminate them. If you don't have that problem, this is not for you. Enhancements to IFX row ID. Been around forever as a semi-hidden pseudo column. for each and every table in an Informix database. Data type of the column is varchar. Column format is fragment ID, row ID, and it's possible to select on these values as well. Selecting on the column values in the past would generate a sequential scan. Works well for equalities currently now, but other kinds of situations, not quite so much. And an enhancement to round robin storage with auto locate. For round robin data fragmentation schemes, normally when a new fragment is created for data in a multi-fragment table configuration, if space is available in the original two fragments, for example, we will continue to add space to the original two fragments and the new one, evenly adding new data across all of the fragments. The result is the third fragment total storage will not ever catch up with storage-wise to the other fragments for the table. In 14.10 FC6, if auto locate set, this behavior will change and allow that third fragment to catch up storage-wise. New empty fragment fills until the time as it has the same storage as the others. There is a potential for unbalanced I/O if the single fragment usage rate is high enough. And we will hit the fragments with the least number of rows and pages. None of the rows will go into the other fragments. Auto locate prevents out of space errors by allocating new space on the fly. Excuse me. So here you can see setting on stat -G, CFG, legacy RR, preserves the original round robin storage allocation with auto locate set. It disables just that auto locate data to fill to the empty fragment behavior. We don't check for the least number of rows in a fragment every time for reasons of efficiency. We do it every 100 insertions. So if the total number of rows in the fragment is off, that's normal, but it's only off by 100 or so. Once the storage between all the fragments becomes balanced within 100 rows of each other, the legacy round robin insertion mechanism will take over again for balanced I/O. Until the storage catches up, I/O will be heavily skewed toward the third fragment, and catch-up time is dependent on the rate of insertions over time. So REPL2 SPL now includes the user and session IDs. This was an oversight originally. CSDK as an install enhancement. .NET provider is .NET assembly. It lets .NET applications access and manipulate data across Informix databases. Does this by implementing several instances in .NET Core SDK, runtime for 3.1, shipped with Windows 64 and Linux x86-64 platforms. Names of all interfaces and methods in .Core provider are the same as .NET framework. .NET Core adds a little more functionality in addition to .NET framework. Embedded link above here has more details. ODBC DSN Advanced option. This new DSN option for update describe or update description and the connection property SQL IFX ATTR update describe is required particularly for blob and clob data types because these data types need special handling in the ODBC driver for setting up blob and clob text context in the driver and requires details of these new data types description from the server. By enabling this option server, we will send description of these data types which will be used by the ODBC driver, and there's a link. Finally, FC5, there's not a lot. We had some shard join enhancements. Shard join fallback is enabled using the following command. Shard join fallback session environment option creates a local temporary table during the data migration to pull the data from the shard participants. The support in clause in the shard expression definition, data moves from old shard definition to new shard definition as applicable. Data not matching the expression does not move. Sample syntax here on the screen. Some miscellaneous changes. Shim total and X shim add are dynamically tunable. Shim total will not adjust downwards if memory is in use, and proposed level drops below that which is in use. And rename table will now accept if exists clauses. And Informix HQ's had some enhancements as well. It's been upgraded to Angular, enhanced the supports. Well, I already read this one, so we're good. That's it for me.